we don't need only carbons in the ring in order to be aromatic. A heterocycle contains a heteroatom, which is something non-carbon within the ring. So they can be aromatic too, as long as we follow those same conditions. We have an unbroken ring of p orbitals. It's planar. So sorry for that typo. It's 4n plus 2. Let's look at pyridine first, which is just benzene with a nitrogen inserted in the ring there. For pyridine, the nitrogen must be sp2 hybridized because it has a double bond to it, right? It's got 3 groups attached, right? The double bond, the single bond, the lone pair. So they'll spread out. What happens? The lone pair must be in one of the sp2 hybrid orbitals, so pointed away from the rest of the ring. That way it can contribute just 1 pi electron, just like all the other carbons would. Okay? So the 2 dots are not part of the pi system. That way we can just still have 6 pi electrons, and it's aromatic. Pyrimidine, same sort of thing. It's 2 nitrogens that are 1,3 to each other in the benzene ring. Both of those lone pairs are in sp2 hybrid orbitals, not participating in the aromatic pi system. Pyrrole, on the other hand, is different. It's a single bonded nitrogen with an H attached. So the nitrogen will still be sp2 hybridized. Okay? That would not normally be the case with a single bonded nitrogen. Normally it'd be sp3 hybridized because the lone pair and the hydrogen would want to spread out from each other as much as possible. But if we sp2 hybridize that nitrogen, if we make its bond angles a little less ideal, we get that energy back and then some, because then I have 1, 2, 3, 4, 5, 6 pi electrons within that system. The nitrogen contributes 2 electrons instead of it's just 1. It contributes both electrons from that lone pair, and we end up with an aromatic system. Imidazole is a little different because we have a pyrrole-like nitrogen that has an NH that's single bonded, okay, as well as a pyridine-like nitrogen that's double bonded. So we've got 2 different types of nitrogens. The NH has the H in the hybrid orbital. Right? The H is in the sp2, where the lone pair is in the p orbital, going up above and below. The nitrogen that's double bonded has just 1 pi electron in its p orbital, just for the double bond, and its lone pair is out in a hybrid orbital, not participating in the aromatic ring. So one of them is not, and that's how we get 6. So as a rule of thumb, those double bonded nitrogens have their lone pair out in the same plane as the molecule. Okay? So just shooting straight out away from the molecule, not in the pi system. Single bonded nitrogens within the ring have the lone pair within a p orbital so that those electrons can participate with the rest of the pi electrons in order to make 6. That happens with all kinds of other heterocycles, things like furan with an O in there. And it has 2 lone pairs, so one will be in the p orbital and one will be in the sp2 orbital. So same thing happens with thiophene, which is like furan just with an S in it. Same sort of thing. One will be in a hybrid orbital, one will be in a p orbital, so that we get 6. So one pair participates and the other doesn't.